I think this is an example with a whole new type of indeterminate form. Notice as x increased that bound, the base is going to this. That exponent is going to this. And I think that should be an indeterminate form because if you think about it, if the base behaves this way much more rapidly than the exponent behaves this way, the whole thing goes to 1. If the exponent behaves this way much more rapidly, the base behaves this way, the whole thing's going to go to infinity, or maybe something somewhere in between. If that's faster, the whole thing goes to 1. If that's faster, the whole thing goes to 0, or maybe something outside that, outside those two values. And likewise, same kind of indeterminate evaluation. And so when I'm one of these three forms, my technique is as follows, well, at least usually. I just give myself more room. So here's what I want to do. Pull down a nifty piece of scratch paper. Let's go ahead and take this expression, this algebraic expression in x. And let's give it a name. Now you may not see why yet, but allow me to take the natural log of both sides. The nice thing about having that natural log is on the right-hand side, I get to exploit that third basic property of exponents by bringing the exponent down to the level of everything else by multiplication. And notice what happens when I try to take the limit as x increases that bound. Gosh, I hope that's showing up clear enough. I think so. So take a peek at how, now that I've got the limit of this product, it's going to be of one of my other indeterminate forms, infinity times 0 situation. Because infinity times 0 situation, am I not just going to dive in and rewrite the multiplication process within the limit as a ratio process? So rewriting x as 1 over x downstairs, that naturally transformed the limit into one of my indeterminate forms for which L'Hopital's rule applies, because now I'm left with a 0 over 0 situation. So in applying L'Hopital's rule, does that give me this? But those two red beasts cancel. I'm left with 5 times 2. Which is that? Oh, but shoot, that doesn't answer the question, does it? Look what I just did. I took the natural log of y. I don't want to take the natural log of y itself. I don't think I said that correctly. I took the limit of the natural log of y. I want to take the limit of y itself without the natural log. So let me come back to the original question. Is it not true that what I'm taking the limit of is something for which I gave an alternative name? And of course, this is more, I hope you're not tired of hearing this, 9th grade high school algebra. Isn't that the same thing as this? Now, there may be a bit of functional composition here, but if the outer function is continuous, then I can bring the limit in. Now look at the exponent. That's the limit of the natural log of y, and I've already figured out that that evaluates to 10. I've evaluated the limit. Now I evaluated the limit with the tools you're learning right now. I have to confess, I do think the original question I asked was a bit silly, because any 9th grade high school algebra student can answer the same question without knowing any calculus. Let me show you that 9th grade alternative. So back in 9th grade, you learned that as n increased without bound, this algebraic expression right here approached some fixed finite real number. You gave it a name, you called it Euler's constant, and we used lowercase e to designate it. And I admit your high school 9th grade algebra teacher couldn't prove that is true, but what he or she did do, he or she pulled out some technology and showed you what happened to this algebraic expression as n got exceedingly large, and you can clearly see it goes to that number. So that being the case, no calculus. Oops, did I forget my 5? Now, these two 2's cancel. Use my basic laws of exponents. I'll combine these but throw it in the exponential position. I just did. Now, as x increases out bound, so does y, because y is just half of x. But of course, this expression right here, as y increases out bound, like you decided much earlier, simply goes to e. I get the same answer, just a more algebraic way of getting there. It's entirely up to you how you want to look at it.